Okay, so today we are going to talk about the reverse triangle inequality. Okay, so what does it say? The reverse triangle inequality says the modulus of A minus the modulus of B, okay, is less than or equal to the modulus of A minus B, like this. This is the reverse triangle inequality. If you have been following my tutorials, I think that you know that last time we did a video on triangle inequality. So this video is a supplement on the triangle inequality. From this, we will be talking about proof by induction. Okay, we'll start with inequality problems so that you can form a nice pattern in your head from triangle inequality to inequality proof by induction, so that it works well. Okay, so this is what we are going to prove: the reverse triangle inequality. So what I want you to do is what you can do for now, you can try to plug in some numbers in there and see if this theorem is correct. But I tell you, just like everything else in mathematics, this theorem was proved. Okay, so to prove this proof, okay, of the triangle inequality, okay, so we're going to say the modulus of A, okay, modulus of A is equal to the modulus of A plus minus B plus B. And okay, we are just basically adding plus B and minus B, which is basically 0 right there. But you will see why we are doing this. Okay, so the modulus of the modulus of A is equal to the modulus of A minus B plus B. Okay, A minus B plus B is less than or equal to the modulus of A minus B plus the modulus of B, like this. So this is basically what you need. If you say the modulus of A minus B, okay, and then add the modulus of B, you can be guaranteed that this side of the equation will always be greater than the left side, which is the modulus of A only. Okay, so we are going to take this part. Let me use a highlighter there. We are going to take this part and this part, since this part is equal to modulus of A. So if we take this part and this part, the part that I've highlighted in green, to say the modulus of A, okay, is less than or equal to the modulus of A minus B plus the modulus of B, like this. So what you want to do is to shift this modulus of B and put it right before the comparison sign. Okay, so the modulus of A minus the modulus of B is less than or equal to the modulus of A minus B, like this. Okay, so this is our first result, which is going to help us get this answer. Okay, so this is our first result, okay, or our first equation, inequality, whatever. So for the second part, we are going to manipulate the modulus of B. The modulus of B is equal to the modulus of B minus A plus A, just like what we did with the first one, is less than or equal to the modulus of B minus A plus the modulus of A, like this. Okay, so we are also going to take this part and this last part. The modulus of B is less than or equal to modulus of B minus A plus the modulus of A, like this. Okay, so with that being said, we are going to move this modulus of A to the other side. We're going to move it before this sign there. Okay, so let me move over to this. Before we do that, let me push this. Okay, so the modulus of B minus the modulus of A is less than or equal to the modulus of B minus A. Okay, so here we are. So if this is our second result. This is our second result. Okay, so with these two results, what we are going to do is we are going to use this concept. We all know that if we say the modulus of x is less than or equal to 2, let's just say, let's do this. Okay, this means that the modulus of what? This means that x lies between 2 and minus 2, like this. This is what it means, right? So that is what we are going to use here. Okay, this is exactly what we are going to use. Okay, so if you look at our results, our previous result, Okay, so I want you to focus on this right hand side of these two inequalities. Okay, so I want you to notice that. Okay, before we do that, let's focus on this second inequality. So for this second inequality, we can rewrite it like this. We can divide everything by -1, and if we divide everything by -1, it will become the modulus of A minus the modulus of B, like this. Is more than or equal to, remember, when we divide by a negative, our sign flips, it changes. It's more than or equal to negative the modulus of B minus A. Okay, so when we reach here, I want you to focus on this part. So on this part, everything that is inside the modulus, we can rearrange everything that is inside the modulus. That means that we can even take this negative and put it before B, right there. It is still okay when we are doing it inside the modulus. You are going to realize this. Okay. Try any number that you want there and try switching the signs. You are always going to get the same answer. Okay, whether the negative is on A or the negative is on B. Okay, let's try -2 and 3. Let's say A is -2, B is 3. Okay, so if we put A right there, it will be positive. If we put 3 there, it will be 3 plus what? 3 plus 2, that is 5. Okay, if we take if we flip, let's say this becomes B. Let's say this becomes B. 2, now 2 is B. B is equal to 2. Then A is equal to negative. B is equal to -2. A is equal to 3, like this. Okay, so B, if we put 2 there, it's -2. Okay, then if we put 3, it's -2 minus 3. The modulus will always be what? Will always be 5. So flipping the signs inside the modulus does not matter. It is still fine. Still gives the same answer. Okay, so we are going to change. We are going to take this sign and put it behind B. So the modulus of A, the modulus of A minus the modulus of B is more than or equal to negative A minus B, like this. So if you look at this part, or this equation, this is our equation 2 remodeled. Okay, so if you look at this equation and the above equation right there, they are similar equations. The only difference is that this one has a negative sign. Okay, so if you look at what we have deduced right there on top, right there, okay, I think you can agree with me that if we write this part first, okay, negative, let's write this part first. We want to combine this equation and this equation using this result that we have deduced here. So negative modulus of A minus B, okay, is less than, because it's less than or equal to modulus of A minus modulus of B, which is from this part, okay, which is less than or equal to modulus of B minus A. Okay, so we have combined this with this using this theorem, or this thing that we have deduced right there. Okay, so if you look at this closely, let me highlight. If you look at this closely, this is similar to what I've written there. Okay, so it means that we can, the x, what is representing x there is this part, which is modulus of A minus modulus of B. So we can change, we can write this part. Okay, since we have derived this part from this statement, we can also do a reverse engineer and then produce something like this, but using this equation, this inequality there. Okay, so our x will be represented by modulus of what? Modulus of A minus modulus of B. Okay, we are going to put it just like what is there. We are going to put it in what? In modulus. So we are going to put another modulus right there and say it's less than or equal to B minus A. Remember here, this is positive. Okay, this is positive, so we have to take the positive part from this statement. Okay, so this is modulus of B minus A. So this is how you do it. You have successfully proved the reverse triangle inequality. Okay, thank you very much.